All right, this is really cool. Here's a 4x8 sheet. Here's a door slab right here. If I actually go and take a look at that door slab, here's the other side of it. So this would be cut out of a sheet, and then here's actual operations that would go on the front of the door. So you can see we just have some fluting. Got my spindle speed, my cutter, what's going on. The feeds and speeds are all displayed. This is a brand new simulation engine through Cabinet Vision. So exiting out of here, if I go back to the pattern view, and I actually run this machining simulation, we'll see that this door is going to be nested on the back. I'll speed this up just a little bit. So we've got some 5mm holes going in. Next will be 8mm holes. There we go. That's for the door. Okay, and we've got some through holes for some connections going in. Then I've got my parts being cut out. Here's the door being cut out. There's the cabinet side. Let's do a little section analysis here. You can see what's going on. We'll close out of this. This is extremely cool. And so if I go into 3D, this is what's being cut out. Let's take a look at it. We could do undermount slides. I mean, anything. This opens up a whole new world. And then also, let's go ahead and do 48 inches here, because really the CNC for now will be a 4x4 machine. So we'll set all that up. Let's go ahead and optimize this back out. And you can see we got the Onefinity nest and the Onefinity parts. Whew, I might be the first person ever to have a post through Cabinet Vision for the Onefinity Elite Foreman. So we'll go in, those warnings were saying it's auto-assigning tools for me. Here's the different sheets being nested out. And I'm thinking what I could do, here's my back, here's the drawer bottom, and then here's my drawer parts. So I think what I could do is a 4x8 sheet, do some registration pins, move all these in, automatically. And then that way I could actually tile and have these parts come out spaced out, registration pin up and down, and just tile it on the machine itself. Wow. This is extremely cool. Don't ask how much it costs to get this working, but man, we officially have the post working. And if I show you guys reports, here's our cabinet. Let's go into the cabinet. Let's take a look at these reports. So here's all of our parts, our ends, drawer parts, materials. And so if I go back and I change my materials for this room, so I go to my materials and I'm actually going to change it from birch to PL2 grain. We're going to say okay. We go back in this cabinet, we can see my finished left end is now PL2 grain. So these materials have changed. We can go back, let's go into the S2M center. We can see that we've got the Onefinity nest and Onefinity parts. Extremely exciting. Hello. Okay, so this doesn't take very long anymore. Super fast nowadays. This update just came out in Halloween. So now we've got our different parts. Here's the door slab. If I actually flip this around, you can see the fluting on that side. So we'll open machining simulation up one more time. Here is this door slab 1A, 1B, and there you go. So you can see that it's actually compensating for the tool radius to cut outside the part, so we get a nice clean flute. You can see the different spacing here. And this is a parametric program, so if I go back and I go and look at this door, and we look in 3D, we can see those flutes. If I take one of these operations, so I get into this door, let's go look at this flute right here. And I'm going to say that its length here is an equation that is listening to the door distance in Y. And so now if I back out and I change the height of this cabinet to 40, and we go and look again, that's the only operation that will move with it because it is actually parametric. So I could actually make all of this parametric, the spacing, the height, the depth, and have it listen. Let's go back into S2M Center one more time. We can go ahead and run, doing my two-sided melamine. There we go. Okay, and we'll take a look one more time at this door. I'm going to flip this door around and we'll do machining simulation. Now we'll see that these are shy, but this one has stretched and is fully parametric with the part itself. Let me slow that down and restart that one more time. I'm going to say stop at tool change so we can zoom in here and see what's going on. Okay. So we can go ahead and go past this one here. We'll let this one do its thing. We'll speed through these. There we go. Okay. So now you can see that my tool is fluting. Now these are going to stop shy, but you'll see the last one will actually go and compensate again for the radius of that bit. So we can speed up just a little bit here. Okay, and now I'm going to go ahead and play, and you'll see that it will cut this part out. Boom. How cool is this? So there's the compression bit, and then check this out. These will be my parts. And so if I open this up, it tells me what side is edge banded. It shows me my operation, shows me my operation in the back here, it tells me the job, the part, the dimensions, everything. This is so exciting. Yes, I know.